I wanted to work through the problems on the review for test one while GoView will provide you with the correct answer once you've done the assignment. I wanted you to kind of see how the problems are worked. I would hope that most of the content in these first few lessons seems familiar to you, that you have seen some or most of this content previously in your math education. You may want to take detailed notes as we work through these problems because you will be able to use those notes on the actual test. You are allotted 90 minutes, so if you have yourself organized in such a way, then you should be able to um, refer to those notes and use them while you're taking the actual test. So question one says, subtract the following complex numbers. Enter the answer in simplest form. And this question is related to subtraction, but the process can also be used with addition. And it's very simple. To subtract or even to add complex numbers, you want to combine like terms. Okay, so you want to combine the real numbers with the real numbers and the complex numbers with the complex numbers. Now, I like to go ahead and distribute the negative sign. Remember that there's an understood 1 in front of this second parenthesis, and so I'm going to distribute that negative 1 so that I have negative 4 plus 4i minus 1 times negative 6 is positive 6, and minus 1 times positive 9 is minus 9i. And then I'm going to come back and I am going to combine like terms. In this case, we're going to combine the real numbers, those without the I. So negative 4 and plus 6 would give me a positive 2. And then I want to combine the imaginary numbers. Plus 4i minus 9i would give me minus 5i. So when I subtract negative 4 plus 4i minus negative 6 plus 9i, the final answer is 2 minus 5i. We simply combine like terms. Question 2 asks you to multiply the following complex numbers. And to multiply these two complex numbers, notice that you have a binomial or a two-termed problem times a binomial or a two-termed problem. And we learned a while ago in relationship to polynomials that to do that we use the process called FOIL. FOIL stands for first, so we multiply negative 4 times negative 1, which gives me positive 4. Outside, negative 4 times positive 6i is negative 24i. Inside, 3i times negative 1 is negative 3i. And last, 3i times 6i is positive 18i squared. The piece you have to remember when you're dealing with complex numbers is that you should never ever leave I squared in an answer, because I squared by definition is negative 1. I squared by definition is negative 1. Your final answer, if it contains anything, should only contain I, not I squared or I cubed or I to the fourth. So I'm going to replace I squared with negative 1 so that I have 4 minus 24i minus 3i plus 18 times the negative 1. And then I'm going to work through that problem doing the math. I have 4. I'm going to combine my like terms here. Negative 24i minus 3i would give me negative 27i, plus 18 times negative 1 is minus 18. Then I'm going to come back and combine my like terms, my real terms. 4 and minus 18 gives me negative 14 minus 27i. So when I multiply negative 4 plus 3i times negative 1 plus 6i, the final result is negative 14 minus 27i. Question 3 is a reasonably straightforward question. It gives you a function. The function c is defined as c of x equals negative 2x minus 4, and you're asked to find c at 2. This notation may be new to you, but basically this says to plug 2 in place of x in the function c. It is the shorthand notation that we use in mathematics. We read it c of 2 or c at 2. So basically this is a very straightforward plug and chug problem. So I would have c at 2 equals negative 2 times 2 minus 4. Again, do the math. If you need to, use a calculator. Negative 2 times 2 is negative 4 minus 4, and negative 4 minus 4 is going to give you negative 8. So C at 2 equals negative 8. Question 4 is a similar problem. It says the function g is defined as g of x equals negative 4x minus 3. Find g at negative 1. Again, this notation is telling me to plug negative 1 in place of x in the function g. So again, don't overthink it, don't overanalyze it. It's basically plug and chug. Plug and chug. So g at negative 1 equals negative 4 times negative 1 minus 3. Do the math. Negative 4 times negative 1 is 4 minus 3. 4 minus 3 is 1. So g at negative 1 is 1, and that would be your final answer. So g at negative 1 is 1, and that would be the answer. Question 5 asks you to determine the intervals where the function is decreasing. Okay, here again, don't overthink this. There's fancy math definitions, but decreasing would imply that the graph appears to be going down. The other thing that you need to remember is that when you are stating these intervals, they're stated in terms of the x value. Okay, they're always stated in terms of the x value. Okay, so if I'm looking at this graph, I can kind of tell that it changes direction at this point, and the ordered pair associated with that point is 0, 4. It also changes directions here, and that is the ordered pair 2, 0. And again, I'm looking for where this graph appears to be going down, and it appears to go down between those 2 points. The x coordinates of those points are 0, and 2. We always work left to right, so we begin at 0 and we end at 2 using the interval notation. I used parentheses here because the actual point at 0, 4 and the point at 2, 0 are not included. When you're stating intervals that are increasing and decreasing, you should always use parentheses. The endpoints are never included. Question 6 is a similar question, but it asks where the function is increasing. Again, there's fancy math language that defines increasing, but increasing means that your graph appears to be going up. Again, when you're stating these intervals that you're looking for, you're going to state them in terms of the x values. That is always the case when you're stating the intervals for both increasing and decreasing, or possibly constant. So again, I want to kind of look at those key points where the graph appears to be changing direction. So again, it's the same graph, so it changes direction at 0, 4, and it changes direction at 2, 0. But this time I want to look for where the graph appears to be going up. So it appears to be going up on this section as well as this section. You do have to realize or remember that your graph continues on beyond the edges of the graph, beyond the edges of the computer screen, and so that technically this keeps going forever and ever, which we denote by an infinity, and on the lower end it would be negative infinity. So again, thinking about writing my interval and writing it smallest to largest, I'm increasing beginning at negative infinity until we get to the x value of 0, or, and or is that U looking symbol. It's a set symbol that means or the union. And then it goes up again beginning from 2 to positive infinity. Okay, it's always in terms of the x. Your interval is always the smallest to the largest, and it's in terms of x. Question 7 asks you to identify the local minimum point shown on the graph. Okay, so it's important that you pay attention. This one wants you to find the minimum. Minimum implies you want to find the lowest, and the fact that it's local means that it's probably somewhere in the middle of the graph. Okay, and so if I'm looking at this graph, it looks like my lowest occurs at this point, and that point in terms of x, y would be -2, +1. So my minimum point is -2, +1. Okay, it tells me here to write it as an ordered pair. Okay, and it even reminds you to use x, y. Number 8 is a similar question, but it says identify the local maximum point. Okay, so that's the highest point of the function, and again it should be a point, so it's written as an ordered pair. And so looking at this graph, which is different, I have this point here that looks to be the highest, and it occurs at 1, 2. So my maximum point, or my local maximum point, is 1, 2. Guys, don't overthink it. It's really common sense. Minimum implies lowest, maximum implies the highest. Number 9 says, given the function below, find the average rate of change. Okay, so to find the average rate of change, you're going to need a formula. Okay, so you want to make sure you're organized and have the formula. I don't recall if the formulas are given at the beginning of the test or not. Okay, so for rate of change, which is delta y over delta x, if you want to relate it to something, average rate of change is similar to the idea of slope when you're talking about a line. We call it average rate of change when we're talking about a curve, such as the one that's given. And so we would have y2 minus y1 divided by x2 minus x1. And it tells us that we want to look at that rate of change between the x value of 4 and the x value of 8. So at 4, here's my x value of 4. I have the ordered pair 4 comma 50. At 8, I have the ordered pair 8 comma 10. Okay, so I have my ordered pairs. I have to read them from the graph. Once I've identified those, it may help you to label them. We have x1, y1, x2, y2, and then we're just going to plug and chug, just like if we were figuring the slope of a line. You would have to identify or be given the 2 points and then do the math. So we would have 10 minus 50, 8 minus 4, 10 minus 50 is negative 40, 8 minus 4 is 4, negative 40 divided by 4 is negative 10. And so my answer, the rate of change between on the interval 4 to 8 is negative 10. The next question is similar, but instead of giving you a graph, they give you an equation. So it requires a little bit more work. You can almost think about it in 3 steps. The first step is going to be to find the value for the function f at 0. The second step is going to be to find the value of function f at 3. And then our third step will be to use those 2 things to find the average rate of change. Okay, so it's a lot of plugging and chugging. It may help you to do it in different colors to help you keep it straight. So if I do f at 0, I would have 3 times 0 cubed plus 4 times 0 plus 4. Okay, continuing on, I would have 3 times 0 cubed is 0, plus 4 times 0 is 0, plus 4. 3 times 0 is 0, plus 0, plus 4. Ultimately, my answer is 4. So I have the ordered pair here would be 0 comma 4. My input was the x, which is 0. My output is the y. Then I'm going to start over, and I've got to plug in 3 into the problem. So I would have 3 times 3 cubed plus 4 times 3 plus 4. Now again, be careful, okay? You can do this in the calculator. I'm going to work it out on my head. I would have 3 times 3 cubed. 3 times 3 is 9. 9 times 3 is 27. Plus 4 times 3 is 12 plus 4. 3 times 27 is 81 plus 12 plus 4. So doing that addition, 81 plus 12 is 93, plus 4 is 97. So I have, for that one, I have the ordered pair 3, comma 97. Again, the X, my input was the 3, my output is the Y. So now I have my two ordered pairs, and I'm going to use the average rate of change formula, which again is delta Y, delta X. So we have Y2 minus Y1 over X2 minus X1. It doesn't matter. I could say here is X1, Y1, X2, Y2. It doesn't matter which one you make the first point and which one you make the second point, but then I'm going to plug and chug. So I have 97 minus 4 over 3 minus 0. So that gives me 93 over 3, which equals 31. So my average rate of change for this function between 0 and 3 is 31. Okay, but you got to treat it like 3 little individual problems. Okay, walk it out in steps, and again, it may help you to use color. Now, question 11 is a multiple choice question. I'm going to go over into GoView in just a minute. But for me, I would probably try to see what this graph looks like to begin with. Either by creating the graph on my calculator or thinking about it. I notice that I have the absolute value bars, and hopefully I know that a basic absolute value is a V shape, and it's typically centered at 0, 0. But this graph has some transformations, and looking at my numbers, plus 5 tagged at the end tells me that I want to move my graph up 5 units. The minus 3 inside the parentheses, or the absolute value brackets, that minus 3 tells me that I want to go right 3 units. And the other thing that I know is because this negative is outside the bracket, that there's going to be a reflection on the x-axis. So I could get myself, using all of that information, I could get myself a rough sketch. Okay, it doesn't have to be perfect because I'm going to try to match Okay, so if I were trying to match this one, I would normally would be at 0, 0, but we're going to go up 5, 1, 2, 3, 4, 5, right 3, and we're going to reflect it, so my V is going to turn upside down. So let's go over and look at the choices in GoView for this particular question. The first option that I see, it is visually turned upward, so I know that's not right. Paying attention to my scale and looking at the second one, let's see, we've gone up 3 and over 5. That's not right. It is flipped over though. The third one is also flipped over, and it looks like we've gone 3 units to the right and up 5. So I'm thinking that that might be the graph. But let's look at the others to be sure. The fourth graph, we have gone right 3 and down 5, but I didn't want to go down. And then the fifth one, we went left and down. Okay, so the one we need is this one right here. Now, again, you could put that in your graphing calculator, assuming you know how. So I'm going to walk you through that. You can do y equals, and we have negative, and then we need to get our absolute value. So we press math, we arrow over to num, and option 1, ABS, stands for absolute value of x minus 3. Then I'm going to arrow out of the parentheses plus 5. And then I'm going to hit graph. And again, it gives me the picture, kind of the same rough draft that I had, that hopefully then you could take from this calculator screen and match it to the one on the computer or on the test. All right, the next one, let me see if I can bring it up. It says, given the graph of f of x below. So they start out and they've given you a graph, and they want you, which of the following graph represents f of x or y equals f of x plus 1 minus 2. Here again, they've given you kind of a basic graph to start with, and you need to think about what kind of transformations are taking place. In this case, you want to go the negative 2, where the minus 2 at the end tells me I want to go down 2. The 1 inside the parentheses with the x tells me I want to go left 1 unit. So again, if I think about this, and this graph is originally centered at 0, 0, and I want to take it left 1 and down 2, my new center point is here. It doesn't seem to indicate that we have a reflection, so we would then just have that basic graph. So again, if you'll think through what the transformations are before you start, that's question 12. Let's see if we can scroll down and see those. Okay, so we're looking for where we've moved the graph left 1 and down 2. Okay, so focus kind of on that center point, left 1 and down 2. Kind of think that one's it, but let's double check the others. Always check the others. Okay, here I went right and up, so I know that's not right. I went left 2 and up 1. That's not right. And I went right 1 and down 2. Again, that's not right. And then this one I went left 1 and up 2. Okay, so our first choice, where we went left 1 and down 2, is the right one. Now, yours may not be the first choice. You'll have to look at your graphs, okay? Because those graphs can be changed in their order. It randomizes which one is where in the choice list. Okay, so pay attention. Question 13 says, determine whether the function is 1 to 1. To be 1 to 1, you can have no repeat in the x values. Okay, to be a function, okay, if you're trying to decide whether something's a function or not, remember we use the vertical line test, or from a table standpoint, you want no repeat in, no repeat in the x values. I got it backwards. To be specifically to be a 1 to 1, we use the horizontal line test, and you can have no repeat in the y values. So if I look at this table and I look specifically at the y values, there's no repeat. So I would say, yes, this function is 1 to 1. Now, why is that important? Because if a function is 1 to 1, then I am able to find its inverse. Okay, so to determine whether something is a function, we use the vertical line test, and I can have no repeat in the x values. To be a 1 to 1 function, we use the horizontal line test, and there's no repeat in the y. Okay, question 14 gives you several graphs, and it wants you to determine which of the graphs are 1 to 1, and it says select all of the correct answers. So you could select more than one in this problem. And we're using, again, to decide whether it's 1 to 1, we're going to use the horizontal line test, which means if I can draw a horizontal line anywhere on the graph and it only crosses one time, then the function is 1 to 1. So in this case, my first choice is 1 to 1. My second choice would be 1 to 1. My third choice is not, because if I draw a horizontal line here, I cross 2 times. So this one is not 1 to 1. And then the fourth one, again, if I draw a line here, I touch 1, 2 times. If I were to draw it up higher, I would cross 1, 2, 3 times. So this one is also not 1 to 1. So 2 of the 4 are 1 to 1, and you should mark both correct answers because of the way the question is worded. It says select all correct answers. All right, question 15 gets into the idea or the composition of functions, and this is another area where color coding may help you. This one wants you to find f of g of x. You may have previously learned this and seen the notation f composed with g at x. This particular textbook uses a different notation. Newton uses a different notation, so just be aware of that. So I'm going to color code these, and my g is going to be in green, and let's put the F in magenta. Okay, so if we're doing this composition, we're going to start with X and sub it into G. So step 1 is I'm going to substitute X into G. So when I do that, I get 5X plus 5. Okay, then I'm going to take that answer. Okay, so use answer from step 1 and substitute or plug into F. So I would have 2 times the answer from number 1, which was the 5x plus 5 minus 3. And then we do the math. 2 times 5x is 10x. 2 times 5 is 10 minus 3. So I have 10x plus 7, when I combine like terms. Again, you sort of treat this one almost like a three-step problem. Again, you start with the x, plug it into g, get an answer, and then you take the answer and plug it into f, and then do the math. The composition is a sequencing of events. You have to follow it in a certain order. You always start with the x and kind of work your way backwards. Question 16 asks us to find and simplify f minus g at 3. And then they define for us function f and function g. Whenever you are adding, subtracting, multiplying, or dividing with functions, you basically do, it's almost like distributing, because I'm going to substitute the 3 into function f. I'm going to substitute the 3 into function g, and then I'm going to subtract the two answers. So again, I can treat this as if it's sort of like a three-step problem. The first thing I'm going to do is find f at 3. Plugging and chugging, but be careful, we have the opposite of 3 squared plus 3. 3 squared is 9, but the opposite is negative 9 plus 3, which gives us negative 6. Watch your signs. So I have negative 6 for f at 3. Then I'm going to come back and I'm going to start over and I'm going to find g at 3. So I would have negative 4 times 3 minus 4. So I have negative 12 minus 4, which gives me negative 16. That's the value for g at 3. I then do the third step where I need to subtract those two answers. So step 3, I would have f at 3, which is the negative 6. So I have negative 6 minus g at 3, which is negative 16. So let's do the math. We would have negative 6 plus 16. Minus 1 times negative 16 is positive 16, which gives us positive 10. So f minus g at 3 is positive 10. That would be my answer. But again, it's a step-by-step process. Okay, number 17. It says find the inverse of the following one-to-one defined function. Okay, it's important to note that you have a one-to-one function, and it tells you that in the problem. And so we want to find its inverse. And again, it's a process. The first step you usually do, and again, I always think about it in terms of x and y. So we really have y equals 7x squared plus 4. And the first step in finding the inverse is to interchange x and y. So I would actually have, when I do that, x equals 7 y squared plus 4. The second step in the process is to solve that equation for y. So if I want to solve this thing for y, initially I'm going to subtract 4 from either side. So I have x minus 4 equals 7 y squared. Still working on solving for y, so I need to get rid of the 7 So I'm going to divide by 7. Divide by 7. So I have x minus 4 over 7 equals y squared. Finally, I want to undo the square, which we do by taking the square root. But remember, when you take the square root, it could be positive or negative. So I have positive or negative square root of x minus 4 divided by 7, and that equals y. Now, you have to go back up here to the original problem to figure out whether you should use the negative or the positive. The initial problem was set up so that y, or x, was greater than or equal to 0, which means it's positive. So ultimately, when you're done, you want the positive y. Okay? So my answer here, my final answer, is going to be the positive square root of x minus 4 divided by 7 equals y. And that represents the inverse of f. 18 also asks you to find the inverse of the one-to-one defined function. So again, it initially tells you that it's a one-to-one function for x greater than or equal to, excuse me, to -1. Okay, so again, I think of the f of x as your y. First step is to interchange the x and y. So we would have x equals -5 times the square root of x plus 1 minus 6. Oops, I forgot to put my y in there, didn't I? Instead of x, that should be my y. Sorry about that. Forgot to interchange them. Okay, so I need to try to solve this thing for y. So I got to do some algebra. Okay, so first thing I'm going to do is add 6. Add 6. So I have x plus 6 equals -5 times the square root of y plus 1. I'm still trying to get the y by itself, so I'm going to divide by -5. It's going to get messy. So we have x plus 6 divided by -5 equals the square root of y plus 1. To eliminate the square root, we have to square both sides. Okay, so when I square both sides, I have x plus 6 squared over -5 squared is 25. Okay, so we take the top number and it gets squared, and then -5 squared, -5 times -5 is 25, equals y plus 1. And then finally, I need to subtract 1 from either side to isolate the y. So I would have x plus 6 squared over 25 minus 1 whole. And that would equal y, which is f inverse. Now there's a variety of ways that you could write that particular expression. So let's go over to Go View, and that was question 18. So I'm going to scroll down to question 18 and see how they have it written. Okay, so they have it kind of written like one of mine, or like I had it. So we have x plus 6 squared over 25 minus 1, which is what we're looking for. Okay, so they leave it in this format, which is kind of nice for you. All right, 19 asks you to find or identify the vertex of the parabola. Now, what you have to remember is that in this form, this is called the vertex form of a parabola, and the vertex corresponds to H and K. The vertex as an ordered pair is H comma K. Okay, so in this scenario, again, be careful. Look at your formula carefully. Okay, the K we just read outright, so K is 2. But the H, it's minus H in the standard formula, so you have to read it as the opposite of H. So I have -3, or the opposite of 3. So that's the opposite of -3 is 3. So my vertex is 3, 2. Now, here again, there's a little bit of way around that, because you could, again, graph this function and then locate your vertex. If I graph that function, if I go to y equals, and I clear out the one from earlier, and we enter x parentheses x minus 3, close the parentheses, square it, plus 2. I can graph it, and then hopefully we can see that we are at 3, 2. Okay, that our low point is at 3, 2. And finally, the last question asks you to determine the x-intercepts. Okay, the x-intercepts. The x-intercepts is the points at which the graph crosses the x-axis. The points at which the graph crosses the x-axis. You're given a picture. Okay, and this is another one of those where you may have multiple answers and it clearly tells you to select all the correct answers. So visually it looks like that I cross at the point -5, 0, and I cross again at the point 2, 0. Now, just be careful, because you may say, well, Miss Ross, we cross at another point. But this point here, remember, is your y-intercept, because it's crossing the y-axis, and that point would be 0, -2. But the question doesn't ask for the y-intercept. It just asks for the x-intercept. Okay, so be careful when you are reading the questions.